Rain with millions of spiders. Spiders are fascinating creatures. They weave intricate webs to catch mosquitoes, and they're not always our allies. Picture walking through a field on a cold morning, only to find it covered in spider webs instead of frost. Creepy, right? Spider moms lay eggs in silk bags, nurturing them until tiny spiders hatch. When ready, spiderlings climb trees, release silk threads, and balloon away. This ballooning allows them to travel great distances. Sometimes, millions of spiders take flight simultaneously, causing a spider rain. This incredible phenomenon is triggered by wind and electric fields. In Australia, spider seasons witness mass migrations of baby spiders, leaving silk blankets on fields. Spider rains can occur anywhere, anytime, leaving us without protection. But they're also a fascinating natural phenomenon. Crater explosions. 8 massive craters plunging 160 feet into the Siberian permafrost have puzzled scientists for over a decade. A new theory may shed light on their origin, suggesting they formed as ancient lakes, once bubbling with natural gas, dried up, exposing the ground to freezing temperatures. This sealed gas vents below, leading to a buildup that eventually erupted, creating the craters. However, the theory presents an exciting opportunity for further research, as not all craters are in areas with historic lakes. Previous studies link them to natural gas accumulations, but only northern Russia hosts these formations. Researchers have identified specific conditions unique to the Yamal and Gidon peninsulas, where permafrost varies greatly in thickness, trapping ancient marine sediments that have evolved into vast gas reserves. The reserves heat up, melting the permafrost and leaving gas pockets beneath, which could be a significant discovery. Great Smog of London. The Great Smog of London, also known as the Great Smog of 1952, was an incredible air pollution event in London, England during December 1952. Unusually cold weather, combined with stagnant conditions, trapped coal-related pollutants in the air, creating a thick layer of smog over the city. Lasting from December 5th to December 9th, it caused significant disruption, reducing visibility and even infiltrating indoor spaces. Government reports estimated up to 4,000 deaths and 100,000 illnesses due to respiratory issues. But recent studies suggest even higher fatalities, ranging from 10,000 to 12,000. This event, unprecedented in severity, spurred significant changes in environmental policies, including the Clean Air Act, 1956, and raised public awareness about the health impacts of air pollution. Hail of frogs. It's not common, but it's certainly an unusual occurrence. People have reported their cars being pelted with frozen frogs during storms. This incredible phenomenon, known as frog rain, has been reported worldwide for centuries. While it used to occur about once a decade, it seems to be happening more frequently in recent years, particularly in Britain. The cause is usually attributed to water spouts, which are pretty amazing. They can pick up lightweight objects like frogs from bodies of water and carry them through the air. When the storm loses its energy and releases its cargo, it can result in a spectacular downpour of frogs. This incredible phenomenon has even been depicted in films like Magnolia. While the question of how frogs end up in the sky remains a fascinating mystery, it's a truly bizarre occurrence that's well worth investigating. Blood rain. Have you ever heard of blood rain? It's a truly amazing phenomenon where blood-like substance falls from the sky as rain. It's been documented since ancient times, including in Homer's Iliad from the 8th century BC. At first, people thought it was actual blood. They associated it with bad omens and used it in literature as foreshadowing. However, the latest scientific findings have revealed that blood rain is actually caused by tiny green microalgae called Trentipolia annulata. Typically, it occurs in localized areas and can last for a short period of time or even several days. In modern times, explanations focus on natural causes like red dust or microorganisms in the water, which is a great step away from supernatural interpretations of the past. Pink Lake. Have you ever wondered how those gorgeous pink lakes form? It's all down to the climate and hydrology of the continent beneath them, with salinity levels playing a big part. The orange-pink hue we all know and love is often linked to the green alga Dunaliella salina, but research suggests bacteria or archaea also contribute. D. salina is incredibly salt-tolerant and thrives in salinity up to 35% NaCl, accumulating red beta-carotene pigment under high salinity, temperature, and light. This incredible pigment, similar to that found in carrots, protects the alga from light damage, giving it an orange, red tint. Initially, the red coloration in French salt lakes was attributed to D. salina, but bacteria and archaea also play a role. Notably, in some Australian pink lakes, the bacterium Salinobacter ruber dominates. Studies by Ken McGrath revealed S. ruber's prevalence in Lake Hillier, challenging D. salina's assumed role. Environmental scientist Thilo Massenbauer, has made an exciting discovery. He suspects that S. ruber is the primary cause of pink lake coloration. Lake Retba in Senegal, which houses S. ruber, reinforces this theory. Additionally, the Archeon Halobacterium salinarum influences lake color, notably in Melbourne's Westgate Park. The precise hue hinges on the balance between D. salina and H. salinarum, influenced directly by salt concentration. Ice shove. Ice shoves, also known as fast ice or I-view in Inupiat, can occur when currents, winds, or temperature changes cause ice to surge from oceans or lakes onto shores. They can reach up to 12 meters high. They can have a significant impact on Arctic communities, and there is growing evidence that they are influenced by climate change. Rising temperatures have been linked to more open water for ice movement. Low pressure systems can destabilize ice sheets, pushing them shoreward. Ice shoves can be an important source of travel and hunting for Arctic communities. It would seem that ringed seals have developed a way of creating breathing holes in ice shoves, which is crucial for polar bears hunting. The Inupiat term for this indicates that it is a regular occurrence in the Arctic. Unexplained sounds. The U.S. National Oceanic and Atmospheric Administration, NOAA, has made an incredible discovery. Using its Equatorial Pacific Ocean Autonomous Hydrophone Array, they have identified a series of unidentified sounds. One of these sounds, called upsweep, was first recorded in August 1991 by the Pacific Marine Environmental Laboratory's SOSIS system. It consists of long, narrowband, upsweeping sounds lasting several seconds each and can be recorded throughout the Pacific. The sound is seasonal, peaking in spring and autumn, which is really quite fascinating. It could be due to changes in the source or the environment. Located at roughly 54 degree S, 140 degree W, scientists believe it may be due to underwater volcanic activity, which is an incredible theory. The volume has been decreasing since 1991, but it remains detectable. Another sound, the whistle, was recorded on the 7th of July 1997 by the Eastern Pacific Hydrophone at 08 degree N 110 degree W. Similar to sounds recorded in the Mariana Volcanic Arc, the whistle's exact source remains unknown because it was detected by only one hydrophone, suggesting it traveled a long distance from its origin.